Hi guys! So for this video, ang pag-uusapan natin is the flexural buckling, compressive strength of members with no slender element. So kung maalala nyo in the previous video, yung topic natin doon is kung paano natin investigate if the section has slender or has no slender element. So ngayon, assuming na yung member natin has no slender element, ano ba yung kanyang flexural buckling compressive strength? Okay? So according dito, the compressive strength for flexural buckling of compression members with no slender element is defined by section 505.3 of NSCP 2015. So, if you have the NSCP, pwede nyong buksan yan and i-verify nyo itong aking i-discuss na mga equations. So, the nominal compressive strength or the PN is defined as, so yung PN is equal to FCR times AG. This is NSCP equation 505.3-1, no? Where AG is the gross area of the section and FCR is defined below. Okay, yung AG nasa appendix lang naman to or literally yung cross-sectional area lang naman ng section natin. However, yung FCR, may formula yan. Depende sa code. And according to the code, kapag yung KL over R nyo daw is less than or equal to 4.71, the square root of E over Fy, or Fe is greater than or equal to 0.44 Fy. Wait lang, no? I-edit ko lang yon. Dapat malaki to. Okay? So, yun. Ayan, balik na tayo sa discussion. Saan na tayo? So, ito siya. Where, or yung Fe is greater than or equal to 0.44 Fy. Yung formula daw ng FCR is equal to 0.658 raised to, this is an exponent, Fy over Fe times Fy. So, this is an SCP equation 505.3-2. And according dito, the column that falls at this category will undergo inelastic buckling. Okay? So, ayan siya. On the other hand, kapag yung KL over R natin ay lumampas na ng 4.71, the square root of E over Fy, or kung ang Fe nyo is less than 0.44 Fy, so yung ating FCR is equal to 0.877 ng Fe. This is an SCP equation 505.3- I think 3 to. Okay? So, baka mali lang ako. Anyway, ito yung equation natin. So, the column that fall at this category undergo elastic buckling. So, Fe is defined as the Euler's critical buckling stress as discussed in section 4.1. So, yung unang formal discussion natin, yung pi squared E over KL over R squared. Di ba? And according din dito, the student should take note that the compressive strength, yung ating strength reduction factor for LRFD is 0.90 and yung ating safety factor or factor of safety is 1.67 for ASD. Likewise, based on the user note of NSCP section 505.2, the maximum value of the slenderness ratio, KL over R, is 200. So, ibig sabihin po, hindi na po pwedeng lumampas ng 200 ang slenderness ratio ng ating mga compression element. So, this graph or the graph below shows the relationship of FCR and KL over R. So, notice na kapag yung slenderness ratio nyo, ang boundary natin is yung 4.71, the square root of E over Fy. Kapag mas malaki, or kapag mas maliit yung slenderness ratio, ibig sabihin po nun, mas malaki yung FCR. So, yun na nga yung sinasabi ko, kapag yung slenderness ratio ay lumalaki, yung kanyang strength is bumababa. Kasi from the word itself, nagiging slender na siya. And hindi na po inaalaw ng code, ulitin ko lang, hindi na inaalaw ng code na lumampas pa sa 200 yung slenderness ratio kasi hindi na yon economical. Okay? So, gayon man siguro, pwede na natin simulan or i-continue tong discussion by providing an example. So, according dito, steel column, 8 meters long is made of ASTM A992 steel. Yung Fy niya is 345 megapascal. And its shape is W460 by 128 or W18 by 86. So determine its compressive strength both in LRFD and ASD using section 505.3 of NSCP 2015 if for letter A, both ends are fixed. Letter B, one end is fixed while the other end is pinned. And letter C, both ends are pinned. So use the recommended values of the effective length factor. So solution tayo. From the previous video, yung about sa slender and non-slender element, napatunayan natin na yung W460 by 128 has no slender element at Fy equals 345 megapascal. Thus, the provisions of NSCP section 505.3 are applicable. From Appendix A, the properties of the sections are its area is 16,300 square millimeter. The radii of gyration Rx is 197 mm and Ry is 66.8 mm. And from A to C, the author will use Ry to solve for KL over R since there is no lateral bracing provided. Thus, KLX over KLY. Ang ibig sabihin lang naman nito, parang doon sa unang example, imbis na computein nyo pa class, no? Diba kung maalala nyo doon sa video natin sa Euler's critical buckling stress, imbis na computein nyo pa yung KL over RX and KL over RY, dahil alam mo na KLX and KLY are equal, so of course, piliin mo na lang yung RY sa computation kasi that is less than RX and most likely, siya ang magbibigay ng mas malaking critical slenderness ratio. Okay? So, sige, simulan na natin yung discussion. So, for letter A, both ends are fixed. The illustration is here. Yung unsupported length niya po is 8 meters and yung kanyang supports ay parehas fixed. From table 4.1, the value of K if both ends are fixed is 0.65. So, check natin yon kung tama siya. Pakita ko lang yung module. So, di ba ito yung module natin. Wait lang Yung table 4.1, nandun yun sa video 4.1 natin regarding sa Euler. So, ito po siya. Kapag parehas fixed, di ba, katulad ng sabi ko, kapag parehas fixed, ibig sabihin, yung recommended according sa problem class, we are going to use the recommended value. So, that is 0.65. Okay? So, 0.65 siya. Balik na tayo dito. So, therefore, ang gagamitin natin to compute for the critical slenderness ratio is 0.65 ng 8 meter or 8,000. Again, ang gagamitin mong R is 66.8. So, equal 77.844 siya. Walang unit ang slenderness ratio, di ba? Kasi magka-cancelled out din naman siya. Okay? So, sige. Solve for the value of Fe using the Euler's critical buckling formula. So, pi squared E all over KL over R squared. So, that is pi squared times 200,000 divided by 77.844 squared. So, yung Fe natin is 325.746 megapascal. So, next is i-determine natin if our column will undergo elastic or inelastic buckling, then solve for FCR. So, di ba nga, ang ating rule, if yung Fe is greater than, equal, or less than 0.44 Fy. So, kung ipa-flash ko siya dito para ipakita yung code, wait lang, ito yung kasi yung mismong module. Ayaw ko nang bumalik doon sa previous slide. So, ito yung ating code. Kung ang Fe natin, di ba, is greater than or equal to 0.44 Fy, ito yung formula ng FCR. Otherwise, kapag less than, ito siya. Hindi ko gagamitin tong una. For consistency purposes, hindi ko to gagamitin. Although, karamihan ng libro sa steel design, ito yung ginagamit. Pero ako, I am going to use this one. Yung relationship ng FE saka ng FY. So, basta tandaan nyo na lang based doon sa ating kapag greater than or equal, ito siya. Kapag less than, ito po. Okay? So, sana malinaw tayo doon. Then, let's go back to the discussion. So, yung FE is di natin alam. Tapos, kay 0.44 FY. So, yung 325.746, ito yung kako-compute pa lang natin na FE. 0.44, ang FY po natin ay 345. So, 325.746, it is finally known na that is greater than 151.8. And as I said a while ago, that is greater than, so therefore, inelastic buckling siya. Okay? Kapag inelastic buckling ang mangyayari, ibig sabihin, itong formula ng FCR ang gagamitin. So, sana clear tayo dun, no? So, FCR is 0.658 raised to FY over FE times FY. Nagkamali lang po ako ng nasulat. This must be times FY, okay? So, yun din naman, FY ang nakalagay dyan. So, 0.658 raised exponent to what? 345 over 325.746 times 345. Kapag kinompute nyo siya, ang FCR natin is 221.463 megapascal. Okay? So, may FCR na tayo. Pag nahanap nyo na yung FCR, ang gagawin nyo na lang is kailangan nyo na lang i-multiply yun ng area, then mahahanap nyo na yung LRFD and ASD strength. So, dito, PN is FCR times AG. So, 221.463 times 16,300. So, that is equal to 3,609.85 times 10 cube Newton or 3,609.85 kilonewton. Ito pa lang yung nominal strength. So, kailangan pa natin mahanap yung LRFD which has a reduction factor of 0.9 and yung ASD which has a safety factor of 1.67. So, ito na siya. Ang gagawin nyo lang, itong 3,609.85, multiply nyo lang ng 0.9 for LRFD. So, ang sagot natin is 3,248.87 kilonewton. Meanwhile, in ASD, yung 3,609.85 divide natin ng 1.67. So, ang ating ASD strength is 2,161.59 kilonewton. So, ito na po ang sagot sa letter A. So, for letter B na tayo. What if, according to the problem, one end is fixed while the other end is pinned? So, kung babalikan nyo yung same table natin, which is table 4.1, I believe, hindi ko na siya kailangan ibalik dito sa video na to kasi mahahanap nyo na yun provided na nahawakan nyo yung module nyo. So, from table 4.1, the value of K, if one end is fixed support while the other end is pinned support is 0.8. Remember na recommended values ang hinahanap natin. So, the critical slenderness ratio is, ito siya, 0.8 na ngayon times 8,000 stands for 8 meter. Yung 66.8, yan yung ating RY, di ba? So, ang sagot is 95.808. So, therefore, hanapin natin yung Euler's critical buckling stress kasi yun yung kailangan natin. Fe is equal to pi squared A all over KL over R squared. So, pi squared times 200,000 divided by 95.808 squared. So, ang ating critical buckling stress, nasobrahan ako ng equal sign. Baguhin ko lang. Ayan siya. So, 215.043. So, ito na siya. Then, next tayo. Determine if the column will undergo elastic or inelastic buckling. Then, solve for FCR. So, same logic. Ito ulit siya. And katulad nung nasa natin, lecture, kapag greater than or equal, ibig sabihin inelastic buckling. Kapag less than, that is elastic buckling. So, therefore, yung FE natin is 215.043. Yung FY is 345. Finally, na-figure out natin na yung FE pa rin natin is greater than 151.8. Ibig sabihin po, the column will undergo inelastic buckling. So, kung ano yung formula natin kanina, yun pa din ang gagamitin natin ngayon to compute for FCR. So, FCR is equal to 0.658 raised to Fy over Fe times Fy. So, FCR is equal to, ayun, naulit na naman tong equal sign. Erase ko lang siya. FCR is equal to 0.658 raised to 345 over 215.043 times 345. So, ang FCR natin is 176.276 megapascal. And of course, multiply mo lang po siya ng area. So, PN is equal to FCR times AG, which is 176.276 times 16,300. Ang PN natin is 2873.30 times 10 cube Newton or 2,873.30 kilonewton. Again, gamitin nyo lang po na yung ating LRFD reduction factor ay 0.9. Yung load reduction yung factor of safety sa ASD is 1.67. Ito na siya. So, 0.9 ng 2,873.30. So, ang ating LRFD strength is 2,585.97. Meanwhile, ang ating ASD strength is 2,873.30 divided by 1.67. That is 1,720.54 kilonewton. So, yun lang naman ang sagot natin dyan. Lastly, for letter C, both ends are pinned. So, yung support dito class ay parehas pinned. Ibig sabihin, from table 4.1 ulit class, yung value ng K natin kapag both ends are pinned is 1.00. Thus, the critical slenderness ratio is KL over R is 1.00 times 8,000 divided by 66.8. So, that is 119.760. After nyong mahanap yung critical slenderness ratio, hanapin nyo na yung value ng Fe. So, di ba parang paulit-ulit lang naman ang solution natin dito. So, which is pi squared E all over KL over R squared. So, pi squared times 200,000 divided by 119.760 squared. So, ang sagot natin doon is 137.628 megapascal. And kapag nahanap nyo na po yung Fe, ang magiging next step is i-determine natin if the column will undergo elastic or inelastic buckling, then solve for FCR. Balik ka ulit dito kay Fe na di natin alam kung less than, equal, or greater than 0.44 Fy. So, 137.628 blank 0.44 times 345. This time, 137.628 is less than 151.8. So, ibig sabihin, dahil less than na po siya, mag-a-undergo na yung column natin ng elastic buckling. So, at least, mako-cover natin what if mag-elastic buckling na siya. In that case, ang formula na natin ngayon to compute for FCR is 0.877 ng Fe. So, 0.877 ng 137.628. Ang FCR natin is 120.700 megapascal. So, at least meron na tayong FCR. Pag nahanap nyo na yung FCR, balik ka ulit sa dating gawi, solve for the nominal compressive strength and the LRFD and ASD strength. So, una, multiply mo lang yung FCR ng area. So, that is 120.700 times 16,300. So, that is equal to 1,967.41 times 10 cube Newton or 1,967.41 kilonewton. Again, for LRFD, the reduction factor is 0.9. For ASD, the factor of safety is 1.67. So, for LRFD strength, that is 0.9 ng 1967.41. So, that is 1,770.67 kilonewton. Meanwhile, for ASD, the strength is 1,967.41 divided by 1.67. Ang sagot natin is 1178.09 kilonewtons. So, yun lang ang solution natin regarding sa NSCP provisions ng pagdetermine ng flexural buckling compressive strength ng mga members na walang slender element. So, thank you so much for listening and watching, and bye-bye!